Hello everyone, in this video we'll learn about shell sort, a sorting algorithm that improves the performance of insertion sort. We'll understand how it works, what a gap sequence is, and see a step-by-step example. Shell sort, an efficient improvement of insertion sort. Definition. So the shell sort is an in-place comparison-based sorting algorithm that sorts elements by comparing elements separated by a gap and gradually reduces the gap. Purpose: to reduce the number of shifts needed in insertion sort, to move elements closer to their correct position faster, efficient for medium-sized datasets. Concept of gap sequence and sublists. What is a gap? A gap is the distance between elements being compared. Instead of comparing adjacent elements, like in the insertion sort, shell sort starts with a larger gap. So as you can see, in this array, we are not just comparing these two adjacent elements. We are comparing 5 with a gap of 6 with the element 3. Sequence. So let's see how it works. First, you have to start from a larger gap, like n divided by 2, and then you move on to a smaller gap, n divided by 4, and then at last you finish from the position of gap 1. So n means the number of elements. For an example, if there are 8 elements in an array, n divided by 2, the first gap sequence. First of the gap sequence is 4, and then 8 divided by 4, 2, and lastly 1. So let's see how insertion sort is used. For each gap, the array is divided into sublists. Insertion sort is applied to each sublist. As the gap reduces, the array becomes more sorted. So let's see a step-by-step example. So if we are given an array like this, first we count the number of elements. So in this array there are 6 elements. So the initial gap becomes n minus 2, which is 6 minus 2 in this case is 3. So compare elements 3 positions apart, because the gap is 3 now. So 8 is compared with 9, which they have a gap of 3, and the 5 is compared with 1, and 3 is compared with 4. So we apply insertion sort to each of these sublists. After insertion sorting sublists, we can get this array. So as you can see, some of these elements are now in a sorted position. So then we'll move on to gap 1, because we want to decrease the gap into smaller ones. So now perform insertion sort on the entire array, because the gap is 1. So we'll compare 8 with 1, and then we swap these values, and then we'll compare 8 with 3, and we'll swap these values, and then we continue the insertion sort until we get the sorted array. Now let's see the difference between shell sort and insertion sort. So if we consider the feature gap, insertion sort always uses the gap 1, comparing adjacent elements. In shell sort, it starts with a larger gap and then reduces until it becomes 1. From a speed point of view, Insertion sort is slow for large lists. Shell sort is faster than insertion. Shifting. Insertion sort takes many shifts, but shell sort only has fewer shifts. Performance. Insertion sort has an efficiency of big O n squared, and the shell sort has the efficiency of between big O n and big O n squared. Use cases. Insertion sort is used for small datasets. Shell sort is used for medium datasets. When to use shell sort? When memory usage must be low, and when the dataset is partially sorted, or when simpler implementation is preferred over complex algorithms. So, in conclusion, shell sort is a powerful improvement over insertion sort using gap sequences. If you liked this explanation, don't forget to like, share, and subscribe for more algorithm tutorials. Thank you.